Imagine holding a golf ball-sized lump of thorium in your hand. This small sphere contains enough potential energy to power your entire life, not just electricity, but your share of hospitals, roads, and all the products you'll ever use. The cost of this raw thorium? Merely $100. If you live for a century, that's just $1 per year for all the green energy you'd need. This astounding potential is what researchers and innovative companies are working to harness. Thorium energy development aims to create a prosperity-driven future. With at least 5 billion people aspiring to achieve the same level of prosperity as those in developed nations, the demand for clean, abundant energy is immense. The goal is to more than double the world's energy production using thorium technology. The key to this ambitious plan lies in developing and mass manufacturing molten salt reactors. Unlike traditional nuclear reactors, these innovative designs can efficiently convert thorium into energy. Some companies envision producing these reactors on assembly lines, potentially churning out 1 unit per day. This approach starkly contrasts with conventional nuclear power plants, which typically take a decade to construct. Molten salt reactors operate on a fundamentally different principle compared to traditional nuclear reactors. In these systems, the nuclear fuel is dissolved in a molten salt mixture, which serves as both the fuel and the coolant. This liquid fuel circulates through the reactor core, where nuclear fission occurs, generating heat. The heated salt then flows to a heat exchanger, where it transfers its thermal energy to a secondary coolant loop. This design offers several advantages. It operates at atmospheric pressure, reducing the risk of explosive pressure buildup. It allows for continuous fuel processing and removal of fission products. And it has inherent safety features, as the fuel can be quickly drained into a passively cooled containment tank in case of emergency. When installed, a thorium power plant could resemble a regular distribution center on the outskirts of a city. Inside, an array of reactor units would generate energy. This model represents a paradigm shift in how we approach nuclear energy production and distribution. The compact nature of these reactors means they can be more easily integrated into existing infrastructure, potentially reducing transmission losses and increasing overall system efficiency. To understand the potential impact of thorium energy, it's crucial to look at the history of human energy consumption. Since 1800, our population has grown from less than 500 million to 8 billion, largely thanks to increased energy availability. This growth, primarily fueled by fossil sources, has driven the global economy through various crises and booms. The transition to thorium energy could represent the next major leap in our energy paradigm, potentially rivaling the impact of the Industrial Revolution. While the public perception of nuclear energy often focuses on its perceived drawbacks, high costs, long construction times, safety concerns, and waste management issues, thorium technology offers solutions to these problems. Contrary to popular belief, nuclear energy has consistently been one of the safest forms of energy production, even accounting for high-profile incidents like Chernobyl and Fukushima. Thorium reactors, with their inherent safety features and reduced waste production, could further improve this safety record. The physics behind thorium reactors differs from traditional uranium-based nuclear power. While current reactors use uranium-235, thorium reactors utilize a process that converts thorium-232 into uranium-233, an excellent nuclear fuel that doesn't exist in nature. This process results in a more efficient neutron economy within the reactor. The thorium fuel cycle also produces significantly less long-lived radioactive waste compared to the uranium fuel cycle, addressing one of the main concerns associated with nuclear power. One of thorium's significant advantages is its abundance. Earth has at least 1,000 times more thorium than uranium-235, and it's found in virtually every country. This abundance makes thorium a potentially renewable energy source, unlike the limited uranium-235 reserves. The widespread availability of thorium could also reduce geopolitical tensions related to energy resources, as countries would not need to rely on a few uranium-rich nations for their nuclear fuel. The energy density of thorium is astounding. It's more than 1 million times that of fossil fuels. This incredible efficiency translates to massive energy production from minimal fuel input. To put this into perspective, a single ton of thorium could potentially produce as much energy as 200 tons of uranium or 3.5 million tons of coal. This high energy density means that thorium power plants could operate for decades on a relatively small amount of fuel, reducing the need for frequent refueling and minimizing transportation and storage costs. Addressing the waste concern, innovative solutions are being developed. New technologies could potentially utilize existing nuclear waste as a kickstarter fuel in thorium reactors, potentially generating 10 times more energy than the original fuel produced. This process could transform nuclear waste from a liability into a valuable resource. By burning long-lived radioactive elements, thorium reactors could significantly reduce the volume and radiotoxicity of nuclear waste, potentially solving one of the most persistent challenges of nuclear energy. Researchers are working on reactor designs that use heavy water to slow down neutrons and feature a thorium blanket for fuel conversion. These designs allow for efficient energy generation and improved neutron economy. The use of heavy water as a moderator enhances the reactor's ability to sustain a chain reaction with natural or low-enriched fuels, further improving the overall efficiency and reducing proliferation risks associated with highly enriched uranium. One of the major challenges in molten salt reactor technology, corrosion, is being tackled through extensive testing and salt purification processes. These efforts aim to minimize corrosion, ensuring the longevity and safety of future thorium reactors. Advanced materials science and engineering play a crucial role in developing corrosion-resistant alloys and components that can withstand the high temperatures and chemically aggressive environment of molten salt reactors. Thorium technology promises several key benefits: potentially lower-cost green energy production, new business models for nuclear energy, and the ability to utilize existing nuclear waste efficiently. The approach could deliver energy at a lower cost than many other technologies, including coal, fusion, wind, and solar. The modular nature of thorium reactors could also allow for more flexible and scalable energy production, adapting to the changing needs of communities and industries. As we look to a future with increasing energy demands and the pressing need for clean power sources, thorium technology stands out as a potential game changer. It addresses the traditional concerns associated with nuclear energy while offering unparalleled efficiency and abundance. With ongoing research and development, we may be on the brink of a new era in atomic power, one that's safer, cleaner, and more accessible than ever before. The development of thorium energy could have far-reaching implications beyond just power generation. It could enable large-scale desalination projects, making fresh water more accessible in water-scarce regions. The high-temperature heat from thorium reactors could also support various industrial processes, potentially decarbonizing sectors that are currently heavily reliant on fossil fuels. Moreover, the compact nature of these reactors makes them suitable for space applications, potentially powering future lunar or Martian colonies. As with any emerging technology, thorium energy faces challenges. Regulatory frameworks need to be updated to accommodate this new form of nuclear power. Public perception and acceptance will play a crucial role in its widespread adoption. However, as climate change concerns grow and the need for reliable, clean energy becomes more pressing, thorium technology offers a promising path forward, potentially revolutionizing our approach to energy production and consumption in the 21st century and beyond.